In this video, we're going to talk more about how to construct the box plot and identify any outliers. Problem number 3 deals with sociology and college graduates. What percentage of the general U.S. population have bachelor's degrees? The Statistical Abstract of the United States, 120th edition, gives these percentages of bachelor's degrees by state. For convenience, the data are sorted in increasing order. So we have a percentage for each state. We've got 10 across, 5 down. So we know we have 50 measurements. And we're going to be doing 3 things. We're going to first construct a box and whisker plot for this data set, which is also known as just the box plot. For part B, we'll identify any outliers. And last, we'll identify the shape of this distribution from the box and whisker plot. So in order to construct the box and whisker plot, we need our 5-number summary. That is, we need the median of the data, the lower quartile, the upper quartile, the minimum value, and the maximum value. So the first thing we'll calculate is the median of the data. So if we have 50 measurements, I know that 25 is halfway, and I've got 10 in each row. So between these 2 measurements will be the middle of the data. So I have an even number of measurements. To calculate the median, I will add the numbers and divide by 2. So you might think, why are we bothering to add these numbers? They're the same number. But sometimes you're going to have measurements that are not the same number, and it will be nice to know how to make the calculation. So I add 24 plus 24, divide by 2. So of course 48 divided by 2 gives us 24. We already knew that. So that is going to be labeled as capital M on our drawing for the box plot. The next thing we need to find is the lower quartile. So basically what that is finding the median again, but we're starting at our minimum value of 17 and working our way to this first number 24 right here that I'm circling. There are 25 measurements, including 17 to this number 24. So halfway is going to be measurement number 13. So measurement number 13, I'll put a box around that and label that as Q sub L for the lower quartile. Then I will look for my upper quartile. So starting at 24 in the red circle, going to the largest value of 38, counting 13, the red box, number 27, is the upper quartile. What we're doing when we're finding quartiles is we're finding that halfway measurement from the minimum to the median, and then the median to the upper quartile. So let's make a list of the information we know. Lower quartile value is 22. Our upper quartile value is 27. The median was 24. We'll need to know those values to construct the box plot. Our minimum value we know is 17, and our maximum value is 38. Now it is helpful to go ahead and identify any values that would be considered outliers, just to make sure that when we're constructing the box plot, our number line goes high and low enough. So we'll go ahead and identify any outliers here. In order to identify the outliers, we need to know what the inner quartile range is. So the inner quartile range, known as IQR, is simply the upper quartile minus the lower quartile. And since we figured out those values already, we'll know that the IQR is equal to 27 minus 22, which is equal to 5. So the inner quartile range is 5. So this tells us there's 5 units between the lower end of the box and the upper end of the box. We're going to use the number 5 as the IQR value now to make some calculations. So the way we're going to detect outliers is to take the lower quartile range minus the IQR times 1.5. And then we'll take the upper quartile range and add it to the IQR times 1.5. So we have values for QL, that was 22, minus our inner quartile range was 5, so 5 will be multiplied by 1.5. That gives us 22 minus 7.5, and that value is 14.5. So really what this tells us is that Any measurement in our data set that is 14.5 or lower will be considered an outlier. And now let's look at the other side of the median. The upper quartile is 27 plus 5 times 1.5. So that means 27 plus 7.5. And that's going to equal 34.5. So any measurement that is 34.5 or higher will be considered an outlier. So I feel it's important to figure out what these values are for outliers so that we can have a more complete box plot. So to draw the box plot, we need to start off first with a straight line, and we're going to look for the smallest value that's either in our measurement or something we calculated for outlier. So our minimum measurement was 17. However, 14.5 was even smaller as one of our outliers. So I need to make sure that when I'm numbering underneath the line I just drew, that I can accommodate numbers as low as 14.5. And then I'll look for the largest number. My max in the measurements is 38, and the upper quartile looking for outliers, I ended up with 34.5. That's a little smaller, so I need to accommodate from 14.5 to 38. So I'll maybe just start out with 0 to 40. About halfway would be 20. And then I can keep cutting my line in half. This is one way to do it. So here I automatically ended up with a scale of counting by 5. And depending on what your measurements are, you might want to count by 1s or 2s, or it just depends on how far apart they are. But we should be all right here counting by 5s. So what I'm going to place above this number line, first of all, is the median. My median value is 24. So I'm going to draw a small vertical line about at 24. And I'll label that capital M. And then I'll draw another small vertical line for the lower quartile at 22, and I'll label that as Q sub L. And finally the upper quartile at 27, and connect these lines with some horizontal lines, and you'll see the box or your box plot. The next thing I need to place is another vertical line representing the minimum value of 17, and then another line marking the maximum value of 38. So I might label this line max and the other line min. And now I'm going to connect this minimum value to the edge of the box. And then I'm going to connect from this upper quartile to my maximum value with a horizontal line. And there's our box and whisker. Now since we've already detected outliers here, 14.5, let's go back to our measurements and see if any of our measurements are 14.5 or lower. Since 17 is our lowest value, we're not going to have any outliers to the left of the median. Checking to the right of the median, 34.5. Go back to our measurements and see if any of our measurements are larger than 34.5. We actually have two measurements that are equal to or larger than 34.5. So at 35, I'm going to put an asterisk indicating I have an outlier at 35, and then at 38, which was our maximum value, I also have another asterisk. And that's standard notation to indicate an outlier. Notice that once we place our asterisks at these outlying values, we will need to adjust where the end of our whisker is placed. So if we go back to the measurements, we'll see that 35 and 38 were outliers. The next measurement prior to that is 34. So at a value of 34 is where we should now adjust the placement of that upper whisker. So 34 is about right here. So I'll need to erase what I had drawn originally, which we didn't know about until we actually calculated where possible outliers would be found. Once we determined that 35 and 38 were outlying values, we needed to go back to our measurements, and we found that 34 was the next measurement right before the outlier of 35. So 34 will be the upper whisker. We'll only need to adjust whiskers if there are actually outlying values and if we're considering those. So the last part of this problem is to identify the shape of the distribution based on the box plot. So what we're going to do is actually take a measurement here to figure out the shape. If we just look at this, we're not drawing smooth curves over our box. We're just looking at how far is it from the minimum value to the median. Compare that to how far it is from the median to the maximum value. And you might say by looking at this, well, it looks a lot farther from the median to the maximum. So to the right, it looks like a longer tail. So our guess would be skewed right. So we can make an actual calculation to determine how long each of these whiskers is. We'll start with the median and subtract the minimum measurement, and our median is 24 minus 17, and that is equal to 7. So it's a distance of 7 units from the minimum to the median. Then we'll compare that to the maximum value minus the median. Our maximum value is 38 minus the median, which was 24, and that's equal to 14. And you can see that 14 is a larger number than 7. So that indicates that is the longer side. That is on the right. So we can say that the shape is mound shape skewed to the right. And there we have another example of using a box plot to also help us indicate outliers.